Lesson 3.5 is going to be solving real-world quadratics without a graphing calculator. So as you can see, we're not going to be using a graphing calculator today. So you have to be ready to be able to solve these without one and using your logic skills and your math skills. Okay. So this is a picture of what a typical projectile looks like. Okay. We use projectiles a lot. They are represented by quadratics that have an a term that is negative, upside down. And oftentimes your projectile, if you're projecting something off of a platform, your y-intercept acts as the height at which you're starting from. So say you're starting from a 30-foot platform. That represents your y-intercept. The maximum, if you're dealing with a projectile, is always the vertex. So if you want to know the time at which the maximum height occurred, if you want to know the maximum height, that's your vertex. The x-coordinate of the vertex tells you when the maximum height occurred, the time when it occurred. The y value tells you what that maximum height actually is. All right. So it says here, they give us the equation, h of t equals negative 16t squared plus 90t. So t and x are the same thing while we get into this problem. H represents height, t represents time. How many seconds will it take for the ball to reach maximum height? So remember, maximum height occurs at the vertex, correct? We have a formula to find the vertex. Well, we have a formula to find the axis of symmetry. What is it? Good, negative b over 2a. So we all know that the axis of symmetry is the x-coordinate of your vertex. All right? So we're going to need to plug in our values into this formula. X equals negative 90 over 2 times negative 16. I'm just plugging into the formula. That's going to give me x is equal to approximately 2.8 seconds. So I am going to be rounding to the nearest tens place today. So just so you're aware. And on the test, if I want you to round, I'll always specify what to round to. I'll never have you guess that. Okay. So what is the maximum height of the ball? So we found the time that the maximum height occurs. How can we use this to figure out the height? Good. We can find the maximum height by plugging the time in. So we're going to take the equation, and I'm just going to plug the time in for t. Okay, that's going to give me h of 2.8 is equal to. Now, to save myself worrying about making a mistake, I type this whole entire thing into my calculator. Okay. So if you want to try it now, feel free to. But if you have questions about it, ask me at the end of class and I can help you personally with how to type this in. So I am getting 127 or 126.6. So 126.6 feet. So that's the maximum height that the ball will ever reach.
Why did you plug it in on each side and
Wait, oh, so this is just a notation that we use. This is saying I'm evaluating the height when t is at 2.8.
It's like the f.
Exactly, it's like f of x. Yep. So as for this problem here, it says give the domain and range of the function. So we're going to find domain and range. Now, we need a little bit of room to do this, so I apologize. I'm going to kind of do it down here at the bottom. So I'm going to kind of zoom in over here so you can see what I'm doing. So sorry about that. So I'm just going to copy down the function. It's h of t is equal to negative 16 t squared. Is it plus 90, right? Or is it minus? Plus, thank you. So we want to figure out what the domain and the range is. Now with any other quadratic in non-real life, we know the domain is all real numbers. Negative infinity to positive infinity. But in real life, infinity doesn't exist. So we have to have realistic constraints. So if we look at our graph here, I know that all the x values my function is going to take is going to be between these two zeros. See how it never gets any wider than that throughout its existence? So we need to find what the zeros are. And we know that the zeros occur when my height is 0. That's why they're called zeros. So I'm going to plug in 0 for my height to figure out where those two values occur. So I'm just plugging in 0 for h of t, my y. And now I have a quadratic that I need to factor. So first thing I need to do for factoring. Now I do want to mention, if you wanted to plug this into quadratic formula, that would work. Your A is negative 16, your B is 90, your C is 0. But we actually can take out a GCF here. Anybody know what that GCF is? Negative 2, right? I can take out a negative 2. And that will leave me with 8t minus 45. Actually, I take out a negative 2t, not just a negative 2. Sorry about that. Because you see how you can take out a t as well?
Yeah.
Okay. So once I get here, what can I do with these two factors? I can set them equal to 0. I can set this one equal to 0. And this one. And then I can solve both of these. So over here, I'm going to divide both sides by negative 2, which means t is equal to what? 0. And then over here, I can add 45 to both sides and then divide by 8, which 45 divided by 8 is 5.6. So what I just did here, this is my endpoints of my domain. Okay? So we know that we don't really care about this part of the domain. I'll explain why. We know that the lowest time you can ever have is 0. Time cannot be negative, right? So the smallest amount of time that can occur is, of course, 0, right at your starting point. And the other one is the furthest we can go to the right, which we just determined is 5.6. Now we're talking about our range. Range is bottom to top. Range is the height. What's the lowest your height can ever go? 0. That's like the ground. And what do we know our maximum height is?
126.6.
Good. 126.6 is my maximum height. Range is height, if you want to write that next to it to help you remember. Domain is time. Okay? Both are limited. Both cannot be infinite. Yes?
Even if you're like underneath the ground, it can still be 0.
Yes, because you're always, whatever you're starting at from your ground is always what you're going to make 0. So I don't know why this is here. How long will the ball take to reach the ground? We know that the ground, yes, go ahead.
Time is always x, right?
Yes, like 99.9% of the time is x. Yeah. Yes.
What if like you're standing on a flat surface, that's your 0. You throw the ball up in the air, it goes down beneath you.
Yeah, I see what you're saying. You're not going to have to do in that complex in algebra 2. That's going to be a more difficult. Yeah, go ahead.
Is height h sometimes, or is it still y?
Height?
Yeah, it's h.
Yeah, height is the h in this problem, if that's what you're asking. So how long will it take the ball to reach the ground? Well, we know that the ball reaches the ground when the height is equal to 0, right?
Yeah.
Would you agree with that? There's only 2 times where that happens, technically. Well, it's where if we started from the ground and then where we come back, which is the final time, right? Which we found out our final time was what? 5.6. So, seconds. So, to make this clear to understand, okay, this part of the graph over here is what's actually happening. Okay, this part over here is the part of the quadratic that isn't really part of what's really happening. You're at the y-intercept, you throw a ball up, and it comes down. When you throw a ball up in the air, it's going to go up a little bit and then come down.
This is exactly what's physics.
It is a little bit like
So
physics.
that's them throwing the ball right there?
Yeah, so like say I was standing on like a little platform, and I were to throw the ball up, and then it would go up a little bit, and then it would come down.
So that's where the ground
That's
is.
what this is doing, yeah.
But why do you start at the y-intercept?
The y, because you don't, when I'm throwing the ball from the ground, I'm not on the ground.
Oh.
You know what I'm saying?
Yeah.
So like right now, say I'm 5'6", so if I were to throw the ball right now, it would be whatever that is in inches off the ground, would be my starting height.
So you'd be the y-intercept.
Exactly. I'd be the y-intercept.
X here.
So if you're
Yeah, 606.
so this is you throwing it directly from the ground.
If I were to start over here, yeah, but if I start here, when the y-intercept isn't at when I'm starting at 0, 0, that means that you're starting from some height. which is typical. You usually do start from some height. 'Cause typically you're not throwing something from the ground. I'm not gonna throw something like off the ground.
So what are we measuring right here?
We're measuring the time. Hi.
Yeah, the time. I'm not able to see it on mine. So can I get this too?
Yeah, I guess we can do that.
That
Okay.
was the one that I missed from last week. So
Okay.
thank you.
All right, continuing on.
From what though? The zero or the X?
Wait, what?
The zero or the X? Where do you mark them?
I would be here. This is my hand.
Okay.
Does that make a little more sense? It's okay. It's gonna make more sense once you do more. I promise. When I first time I did this too, I was like, this is weird. All right. So this one says, at a swim meet, Jeanette dives from a diving board that is 40 feet high. So when you dive from a diving board, do you just like fall off the diving board and go straight down? No, you go up and then you go down, right? So she's diving from a height of 40 feet, right? So we need to, that's what our y-intercept is, where she starts, okay? So we're starting right here. We're going to say that's like 40 feet. This is just an estimation graph, so it doesn't need to be precise. So we go up, and then she comes down, okay? And this right here is my vertex. And whatever this is right here is like when she hits the water. Your x-axis here is basically the water, okay? All right. So we have an equation that models our projectile. Notice that the intercept is 40 because she's starting at 40, okay? Where t represents time and h represents height. So how long will it take to reach the maximum height? So we know to find the time at which the maximum height occurs, we have to use the formula x equals negative b over 2a. Now, anytime they're talking about maximum height, you always have to find the vertex, okay? Vertex and maximum height are like hand in hand, okay? So this is going to be x equals negative 24 over 2 times negative 16, which gives me x equals 0.75 seconds. So it doesn't even take her a whole second to reach her maximum height. She goes right up and then she comes down from there, okay? So what is the maximum height where she reaches? We want to know what the actual height is. So what we have to do is we have to plug the height into the formula. So we're just going to take our formula and we're going to plug in whatever that time is that she reached the maximum height at. Like this. And you can put this all into one big, I'm so used to writing f of x. It's h of x, or h of t. So calculator's going to do all that heavy lifting for me. Negative 16 parenthesis 0.75 plus 24 times 0.75 plus 40. So that will give me 49 feet. So this point right here is at 0.75 comma 45. If you're wondering, if that helps you have a better understanding of what's happening. Okay? So she reaches her maximum height there. After how many seconds does Jeanette enter the water? Well, we know she enters the water when our height becomes what? 0. So we're going to take our function, and instead of height being h of t, we're going to replace it with 0. Because we know that when this is 0, we can find the time at which she reaches that. So to solve this, of course, you could use quadratic formula, but I think there's a GCF we can take out here. Yeah, we can take out an 8. Good, we can take out an 8.
Oh.
Okay, so we're going to take out a negative 8. Are you guys good?
Yeah, we're good.
We're going to take out a negative 8. That's going to give me 2t squared minus 3t minus 5. So I just took out a negative 8, which is a GCF. And now I can use what method? Yeah, factoring the AC method. Very good. So I'm going to use the AC method. And then I'm looking for factors of negative 10 that add up to negative 3, which are what?
Negative 5.
Good, negative 5 and positive 2, right? And then I can divide by what I multiplied by, which was? 2. So this gives me t is equal to 2.5 and t is equal to negative 1 if I set each of these equal to 0, right? Now, I don't care about the negative 8, right? Because we know this is going to be no solution when you set negative 8 equal to 0. Now, of these two answers, one of these gets rejected. Which one do you think we're going to reject? The negative, because time cannot be negative. So that's 2.5 seconds. So it only takes her 2.5 seconds to hit the water. Reaches her maximum height at 0.75, comes back down into the water at 2.5. So does everyone have an understanding of what happened in this problem?
Yeah.
Okay, starting to get the hang of it. Cool. So the next one, example 3 rather. So yeah, this is long. There's gonna be a lot of long ones in here. I'm just warning you guys. The number of bacteria in a refrigerated food is given by the function n of t is equal to. You guys got it. What's up?
Nothing.
Yeah, you can go. I don't know what those things are. So basically we have a formula, and this formula represents the number of bacteria that are created in food based on the temperature, because temperature affects bacteria in food. So T represents the temperature, N represents the number of bacteria. So, what is the temperature T? At what temperature will the bacteria be minimal? What word does minimal sound like that we use often here?
Small.
Minimum, right? And there's only one type of quadratic that has a minimum. It's the one that goes smiley face or frowny face?
Smiley face.
Smiley face is the one with the minimum, right? The minimum's down here. So you can tell that this particular quadratic is a smiley face because its A value is positive. You remember when the A is negative, that's when it's upside down? Yeah. So they want us to find the minimum, and the minimum is also the vertex, right? The minimum and the maximum are always the vertex. You have one or the other, and it's the vertex. So in order to find the temperature where the bacteria will be minimum, we have to find the axis of symmetry. So when they talk about mins and maxes, that's the one you want to use. X equals positive 20 over 2 times 20. So that's when X is at 0.5. So when the temperature is at 0.5 degrees Celsius, that's when you have the least amount of bacteria. So if the refrigerated food is 2 degrees Celsius, how many bacteria can be found in the food? Well, we can find the number of bacteria by simply plugging in 2 for temperature, yep. So n of 2, just the notation, is equal to 20 times 2 squared minus 20 times 2 plus 120, which means n of 2 is equal to, that's 2 parentheses 20 squared minus 20 times 2 plus 120. That's 160 bacteria. Alright. So now we're going to look at some problems that use some skills that you've learned from geometry and other classes to come up with some formulas. Don't be too scared, guys. So this question says, the base of a triangle is 7 less than twice its height. If the area of a triangle is 102 centimeters, find the length of the base. What is the formula for area of a triangle?
Base times height.
Good, half times base times height. So we know in this case the area is equal to what? 102. For the sake of simplicity of solving, I'm going to leave the units off and put them back later. Now we have to come up with one of the formulas for one of the letters. So it says here that the base of the triangle is 7 less than twice its height. So we can say the base is equal to,
2h minus 7.
very good, 2h minus 7. Because it's 2 times the height and then they take 7 away from it. That's how you get the base. Okay? So what can we do with this formula for the base? I can plug it in to the formula. Very good. So I end up with 1/2 h times 2h minus 7 is equal to 102. So I just rearranged everything being multiplied to make it easier. So I distribute, and I get 1 half times 2 is just 1. And then that's going to be minus 3.5h. And then I'm also going to subtract over the 102. So I just distributed and subtracted over, yeah.
Why is it not h squared?
Oh, good question. It is h squared. Thank you. You were right. That was my fault. So we end up with a quadratic, right? Now, does anyone in here want to try to find factors of 100, negative 102 that add up to negative 3.5? No, so when we don't want to do that, we want to use what formula? Quadratic formula.
Why didn't you just move it over?
I just distributed these guys, and then I wanted to move this over because I want it to be in standard form.
But what about, what's that one called where you add it to the other side?
Oh, that's completing the square.
Why didn't you do that?
Because then I'm going to have to take half of 3.5 and square it, and that's going to get nasty. You can if you want, but it will just kind of get, yeah.
I feel like I'm bad at selecting which one to use.
So in a lot of these problems, if it doesn't factor nicely, you typically want to use quadratic formula. That's going to usually be your easiest bet.
Doesn't 103.5 have to be negative?
Yeah, it will become positive. And yeah, I subtracted it over for it to become negative.
Makes sense.
You see what I did there?
Yeah.
Okay. So this is going to give me x equals 3.5 plus or minus the square root of, I think it's 420.25.
Isn't there a negative? Yeah, I thought 3.5 was negative.
It is negative, but remember it's negative b over 2a.
Oh, so you cancel that one?
Yeah, and I see what you're saying. If you make this negative or positive, it doesn't matter because you're squaring it anyways on the inside. So that's going to be the square root of 420.25. So this gives me x equals 3.5. Do you guys all feel comfortable with just doing one of these on your own right now? Okay, then why don't you all be quiet and listen. So, x equals, now, for this question, there's two versions, right? There's 3.5 minus 2.20.5, and then there's plus. Do I need to do the minus one? No, because can distance length be negative? No, so I only care about the plus one. So you can save yourself the time, and you get 12 centimeters. So 12 centimeters. 12 centimeters represents the height, doesn't it? But that's not what the question asked for. What did the question ask for? The length of the base, which is 2 times 12 minus 7, which is 24, 17. Good. So the question actually asked for the base. So yeah, these problems can be a bit lengthy, and they do have a lot of steps. That's why it's so important that you try to make sure you're careful on each step so that you don't make an error. So if you make an error, then you kind of mess up the whole entire thing, and you don't want to do that. All right. Next problem. Yes, go ahead.
Do we have to put like the unit in our answer?
Yes, you definitely want to make sure you put the unit. I'll always remind you though, either at the beginning of the test or it'll be written on the instructions. Additionally, if I want you to round, I'll always say what to round to as well. So this one says the length of a rectangle is 6 meters less than it is wide. Find the dimensions of the rectangle if the area is 27 square meters. So if we have a rectangle, we know that the area is 27 square meters, meters squared. And it says that the length of the rectangle is 6 meters less than its width. So I don't care which one you make length, which one you make width, it's the same thing. So basically the width is maybe this part, and then the length is 6 less than the width, right? So this would be the dimensions of my rectangle. Does everybody see how I came up with that?
Yeah.
Okay. Now, we know that area of a rectangle is what times what?
Base times height.
Base times height or length times width, same thing. So now we're just going to plug into the formula. I've got the width times the length, or the length times the width, is equal to the area. Two dimensions times each other equal to the total area. I distribute the W. And then what can I do with that 27? W squared minus 6W minus 27. And then I can factor it, can't I? What are factors of negative 27 that add up to negative 6? Very good. If I set these equal to 0, I get W equals 9 and W equals negative 3. Which one am I going to reject? Good. So I know that my width is 9 and my length is 3. Because I plug it back in. And that makes sense because 9 times 3 is 27. So you can double check it. All right. We're going to do 6 together, and then I'll give you a chance to try one on your own, but I'll kind of like guide you through it. So you're going to see these problems a lot. This is probably one of the top problems I see on the ACT and SAT come up when I do prep. Okay? So this right here is really, really important, especially at the age you guys are at, juniors, sophomores, freshmen. You guys are coming up to taking the SAT, the ACT, all that stuff. So this is really important. So it says, find 3 positive consecutive integers. So that's like 4, 5, 6, 7, 8, 9. When you take the consecutive integers, what is the spacing between each of those numbers? It's the same, and it's 1, right? So you're always going up by 1 when you're talking about consecutive, correct? So let's pretend our first consecutive integer was x. What would the next one be? X plus 1. The next one would have to be x plus 2. So these 3 expressions represent your 3 consecutive integers. So let's read what they want us to do with those consecutive integers. So this is the first one, the second one, and the third one. Smallest, biggest. So it says the product of the smallest and the largest, so that's x times x plus 2, is 17 more than 3 times the middle integer. Okay? Remember, this is the middle one. This is the largest. And this is the smallest. So does everyone understand how I set that problem up? So now we can distribute here. Distribute. Combine like terms. And then bring everything to the left. Minus x. And factor. So I get x equals 5 and x equals negative 4. Which one of these is going to get rejected? Good, because they said they want positive integers. So my first number is 5, my second number is, and my next number is 7. So if you're ready to try number 6, yes.
When you're factoring like the 20 to the negative 5 and 4, how do you know which one's positive and which one's negative?
I look at whatever this number is here. So I remember my goal is to get it to add up to negative 1. So that's why I have to pick the one. Yep. So as for number 7, the product of 2 positive consecutive even integers. Even. What are 2 consecutive even numbers that you know of? 2 and 4. Not the 3 though. 2 and 4. 4 and 6. What is the gapping between consecutive even integers? 2. So your numbers are going to be x and x plus 2. So go ahead and try it. people are absent today, huh?
Yeah,
So
pretty
many
much.
keyboard.
You guys ready?